This department. Okay, I will start with definition. We are talking about PD, partial differential equations. Now, a partial differential equation. Now, the definition of a partial differential equation. A partial differential equation from the material is an equation that contains a dependent variable with two or more independent variables. For example, if I have partial u, partial x, partial y plus partial u, partial y squared equals 0. This is a partial differential equation. So it has a dependent variable and two or more independent variables. Independent variables are x and y. The dependent variable is u. Whenever you see something like this, it's a partial differential equation, especially if you see partial derivatives. This thing you're seeing here means partial derivative. So whenever you see something like this, a partial differential equation, it can be written in this form: u xy plus u yy equals 0. Even if it's written in this form, it's still a partial differential equation. This u xy means this is the dependent variable u depending on two independent variables x and y. These are the partial derivatives of u with respect to x and y. This is the form of a partial differential equation. Now, let's talk about linear partial differential. There are some differential equations that are linear. There are some that are non-linear. Anytime you hear linear partial differential equation, what does it mean? Now, I will use this example. This is a linear partial differential equation. Now, on a more broad scope, now let's consider a differential equation. A u xx plus b u xy plus c u yy plus d u x plus e u y plus f equals g, where a, b, c, d, e, f, and g are functions of x and y. Now, if you have this is a differential equation. This thing I wrote here, because you see that you're seeing uxy here. It means partial derivative. See, uxx is partial derivative of u with respect to x twice. This uxx is the same thing as partial u, since it's second derivative, partial square u. This is square, sorry. Partial square u over partial x square. This is the meaning of this. Xx is partial x square. Xy is partial square u over partial x partial y. Now, these are second order partial differential equations. Now, when you see partial derivatives like this, and they have coefficients. Look at the coefficients of this partial derivative. The coefficient of this one is a, coefficient of this one is b, coefficient of this is c, coefficient of this is d, the coefficient of this one is e, and this is f. This is a constant f, and this is a constant g. When you see a differential equation in this form such that these coefficients, they could be numbers or they could be linear functions, functions of x and y, such that the derivatives here are not squared. If there's a square here, then this becomes non-linear. I don't know if you're getting me. If there's a square here, this becomes non-linear. But as long as the derivatives are not squared, what I mean is, remember, this can be written as this. So if this one is squared, that is, if this is squared in this form, then this differential equation is non-linear. But when there is no square, then it is a linear differential equation. so far as it has coefficients that are either numbers or functions of x and y. A typical example, if I have a 3x uxx plus 4y uyy equals 5. This is a linear differential equation. Because first, you see that the derivatives are not squared. These derivatives are not squared. They are all single power. And then the coefficients are functions of x and y. So this makes it a partial differential, a linear partial differential equation. I believe you understand what we mean by linear. Then, the next thing is homogeneous. Homogeneous. Now, if G, look at the general form. The general form. If G is equal to 0, if G is equal to 0, such that, what I mean by that is, if the right hand side of a differential equation, of a partial differential equation is 0, if this right hand side, everything on the right hand side is 0, then that differential equation is said to be homogeneous. I repeat, if the right hand side of a differential equation is 0, that is, if whatever is on the right is 0, then that differential equation is said to be homogeneous differential equation. I believe you understand me. Now we'll talk about some examples. Let's talk about an example. Now we are giving a solution to a differential equation. They say verify that uxt equals e minus kt sine t satisfies the heat equation. This is the heat equation in one dimension. The one-dimensional heat equation. Now, we want to show that this uxt, remember, we've been talking about the derivatives uxx plus uxy and so on equals to whatever, maybe 5 any number. This is a partial differential equation. I told you that it is partial differential equation because it has one dependent variable u with and has two independent, two or more, but for this case we are talking about two independent variables, x and y. Remember that the dependent variable is the u, the independent variable is, in this case we have x, in this case we have x and y. I believe you get me. So when you are solving a differential equation, what you get is the function u itself, not the derivative. Remember, this can be written as partial square u over partial x squared. So when you solve this, you are getting this u is equal to something. Whatever I have is the solution to this differential equation. Now, this u is depending on that x and y. So u here is depending on x and y, meaning that whatever you get is a function of x and y. That is, whatever you get is written in terms of x and y. That is, you could write, the answer could be 3x plus cos xy. Now you see that this is written in terms of x and y, and also, are you seeing any other variable here? Are you seeing u here? Are you seeing t here? Are you seeing w here? No, just x and y. So this solution, that is u, is this solution. U is the function of x and y. So if you say u is a function of x and t, it means that whatever is on this side is just x and t. 3x plus cos tx. No y, because if I include y, if I'm going to put y, then u is also depending on y. So in this case, if I include y, then u is a function of x, t, and y, because there are x, t, and y here. I don't know if you are getting me. That is what I mean by uxt in this case. So uxt is a solution to this differential equation. Now, but the solution is this. We want to show that this solution satisfies this differential equation. How do we do that? The first thing you do is you write your solution. U is equals to e minus kt sine t. And then, because you want to get this, look at the left hand side has the second derivative. Partial square means second derivative of u. You are differentiating u twice. So you have to differentiate this u twice with respect to x. So you differentiate u